Hello everyone, my name is Masaria Lowland. I'm a Kenyan. I'm a teacher by profession who has taught for a period of 11 years. My teaching subject is chemistry. I want to demonstrate on how I carry out my classes back at my school. I'll begin by taking you through my lesson plan. So, when you check on your screen right now, you can be able to see that I have a lesson plan. Let me just scroll up. There is a lesson plan which has been made in such a way that we have the teacher's name, myself, Masaria Lowland. Then my teacher's number, which is 496175. The form that I want to teach today is Form 1. Then the duration is 15 minutes. The topic that I've taught to teach is air and combustion. So in air and combustion, I want to look at the subtopic laboratory preparation of oxygen gas. In this lesson, I have objectives and I have the rationale for the lesson. Then we have the background information or background knowledge and skills the students ought to have for them to be able to understand what I'm going to teach today. We have the reference materials. The materials are right down here, which we are going to use in the laboratory preparation of oxygen gas. Going to the next slide on my lesson plan, you can be able to see on the screen, on the left hand side of the screen, that we have the lesson plan arranged in stages, where we have the first stage or the time taken, where we have the introduction, we have the lesson development, the conclusion, and the evaluation of the lesson. In the second column of my lesson plan, you can be able to see we have the teaching and learning activities. Then in the third column, I have arranged the learning points. So as we move on with our class, we shall be able to look at these learning points. Then I have my remarks column in the lesson plan. This remarks column, I'm going to fill it immediately after this live lesson presentation. Back to the lesson now. I'm going to present my lesson using PowerPoint slides. So I can be able to load my slide, as you can be able to see on the left hand side of your screen, that I have a live lesson presentation. The class is Form 1 and the subject is chemistry. As I told you earlier, that I'm going to look at laboratory preparation of oxygen gas, and I've called this as lesson number 1, and of course I'm the one who is going to present it. Now, going to the next slide, you can be able to see on your screen I have the methods of preparing oxygen gas. The methods of preparing oxygen gas, of course, there are many, where we have highlighted some of them. The first one being decomposing hydrogen peroxide using manganese for oxide. Then the second one is, you can be able to see on the screen, reacting sodium peroxide and water. And the third one is heating potassium chlorate 5. The last method of preparing oxygen gas is heating of metal nitrates. But today in this lesson, I'm only going to illustrate the first one, which is decomposing hydrogen peroxide using manganese for oxide. So going to the next slide, you can be able to see that, if I may just push the slide so that you can be able to see everything, you can see that the key question in my slide is that, how is oxygen gas prepared in the laboratory? How is oxygen gas prepared in the laboratory? So, how do we prepare this gas? Then we will need to go to the second slide, which is showing the chemicals or the materials that we shall require. The ones that I've listed in the first column of this table. Then in the second column of this table, I have listed the apparatus that I'll need for me to carry out this experiment. So you can be able to see each of the chemicals has specifications, the amount that we need. For example, if I may use the second chemical, 3 grams of manganese 4 oxide. And then if you look at the second column, again, I've specified the quantities that we require, the amount that we require, the number of apparatus. For example, if I may use the first set of apparatus, I need 2 gas jars. Secondly, I need 1 beehive shelf. Then all the way to the last set of apparatus, which are 2 gas jar covers. So, if I may move to the next slide, you'll be able to see that I've outlined the procedure through which we need to go step by step so that we prepare this gas that we are referring to as oxygen gas. So, step number 1 is half fill a trough with tap water. Then the second step is place a beehive shelf into the water. Place a beehive shelf into the water. And the third one is completely fill the gas jar with water and invert it onto the beehive shelf. And lastly, as you can be able to see on the screen, I have the last step, which is clamp a flat-bottomed flask and set up the apparatus as shown. So this is going to lead us into the next slide. So the next slide, you can be able to see it's simply a setup of apparatus that have been arranged, the ones that I was talking about in the lesson plan. So I have the complete stand and clamp. So this is the clamp, and the whole of this, if you can kindly follow my cursor, is the stand. Then we have this apparatus right up here, which is called the dropping funnel. The dropping funnel, it has a tap. Then we have this other apparatus, if you can kindly follow my cursor, it is called the flat-bottomed flask. So this flat-bottomed flask is going to be used as a gas generator. This is the apparatus from which the gas will be produced. So that gas, once produced, it will move via this delivery tube, and then it will be it will move through the water and be collected in this apparatus that we refer to as a gas jar. Of course, there is already some water on in the water trough that we had talked about earlier. This is called a beehive shelf. Of course, we were using hydrogen peroxide. So this hydrogen peroxide is the one that we are going to pour through the dropping funnel. Then we shall open the tap of the dropping funnel. The hydrogen peroxide will be able to move and react, or it will be decomposed by the manganese 4 oxide, and then we shall be able to produce our gas, and the gas will be collected right here, which is oxygen gas. We will go to the next slide, which is showing, this is just but a screenshot of a video that I'm about to play. But just before we go to the video, you can be able to see some of the apparatus that we are talking about. Like we have a gas jar, another gas jar. I can see a water trough. This is the water trough. On it we have the water. Inside the water trough we have a beehive shelf. Then these apparatus, if you can also kindly follow my cursor, it is referred to as a delivery tube. Then of course you can be able to see the chemicals. This one is referred to as manganese 4 oxide. It's black in color, and we also have the hydrogen peroxide, which is a colorless liquid. So we will be able to play the clip so that we understand how the gas is prepared in the laboratory. It is a short video clip, just about 3 minutes. Let us be able to look at the video and learn how oxygen gas is prepared in the laboratory. Of course, we shall also be making observations to ensure that we understand how this oxygen gas is prepared in the laboratory. So as I load the video, kindly watch and enjoy the video as you learn. That's the first gas jar of oxygen gas that we just prepared from that video. So can you watch as we look at how we'll be able to test the gas. But just before that, we want to collect another gas jar of oxygen gas. Now we want to test for oxygen gas. Oxygen gas is normally tested in the laboratory using a glowing splint. So how is it tested? Let us observe. So that is it concerning the laboratory preparation of oxygen gas. Back to the slides that we are using in this lesson, we can be able to see that this is the setup that we had earlier on, and of course we have the arrangement of apparatus is shown, and therefore we need to go to the next slide. Of course, the next slide is having the observations, whereby we have bubbles of a colorless gas are produced in the flat bottomed flask. We were able to see that. Then in the second observation, we have the gas produced is collected over water in the gas jar. And of course, the third one is gas produced relights a glowing splint. This is where we really focused, and that's why I had asked you to be keen. And we saw that the gas produced relighted a glowing splint, and that is the confirmatory test for oxygen gas. So if we move on to the next slide, as we conclude, you can be able to see that we have a word equation for the reaction that was taking place, whereby we have hydrogen peroxide. Hydrogen peroxide, as you can be able to follow my cursor, is acted upon by manganese 4 oxide, so that we produce oxygen and water. But we are very much interested with oxygen. So this is referred to as the word equation for the reaction that was taking place. Then when we go to the physical properties of oxygen gas, we were able to see that the gas was colorless, the gas was also odorless, and of course the gas is tasteless. And lastly, we are seeing that the gas is slightly soluble in water, and that's why it was collected by a method that we refer to as over water method. Now, that is how oxygen gas is prepared in the laboratory, and that concludes my lesson. Thank you very much. Thank you so much.